Join me as I dive deep into the mysteries of the Kuiper Belt and take on the challenge of uncovering how it impacts our climate here on Earth. The Kuiper Belt is a vast, donut-shaped region of our solar system, located beyond the orbit of Neptune, and it's home to a multitude of small, icy bodies, including dwarf planets like Pluto, as well as countless comets and asteroids. This region is significant not just because of its impressive size and the number of objects it contains, but also due to its potential influence on our planet's climate. The Kuiper Belt's icy bodies can occasionally have their orbits perturbed, sending them towards the inner solar system, where they can have profound effects on Earth's atmosphere and climate. Understanding how phenomena in the Kuiper Belt, such as comet activity and asteroid collisions, could influence climate patterns on Earth is a complex and intriguing challenge. Comet activity, for instance, can lead to increased dust and gas in the inner solar system, potentially affecting Earth's atmosphere. This can happen when comets, originating from the Kuiper Belt, approach the Sun, causing them to release large amounts of dust and gas. These materials can then interact with Earth's atmosphere, potentially cooling the planet by blocking sunlight. On the other hand, asteroid collisions within the Kuiper Belt can also have significant effects, as they can create massive dust clouds that spread throughout the solar system, affecting the amount of solar energy that reaches Earth. The interaction between objects in the Kuiper Belt and the inner solar system is critical in understanding potential climate impacts. For example, when comets or asteroids are perturbed from their stable orbits in the Kuiper Belt, they can embark on a journey towards the Sun, potentially crossing Earth's orbit. If these objects are large enough, their gravitational influence could affect Earth's orbit, leading to changes in the distribution of solar energy the planet receives. Furthermore, the dust and gas trails left behind by comets can serve as a source of meteoroids, some of which can enter Earth's atmosphere, producing spectacular meteor showers, while others might contribute to the gradual accumulation of extraterrestrial material on our planet. The complexity of these interactions and their potential implications for Earth's climate are still being unraveled by scientists. Research has shown that the Kuiper Belt has been a significant source of short-period comets, which are comets that take less than 200 years to complete one orbit around the Sun. These comets, originating from the Kuiper Belt, have been responsible for some of the most spectacular cometary displays in history, and their impacts on Earth's climate, although still a topic of debate, are believed to be substantial. The study of these comets and their effects on our planet is an active area of research, with scientists using advanced computer models and observational data to better understand the mechanisms by which the Kuiper Belt influences Earth's climate. Discussing the central challenge of understanding Kuiper Belt phenomena and their influence on Earth's climate also involves examining the role of asteroid collisions. When asteroids collide in the Kuiper Belt, they can create massive clouds of dust and debris. This debris can then be perturbed into orbits that bring it closer to the Sun, where it can interact with Earth's atmosphere, potentially influencing climate patterns. The exact mechanisms by which this debris affects Earth's climate are complex and depend on various factors, including the size and composition of the debris, as well as the timing and location of its interaction with Earth's atmosphere. Scientists are working to better understand these processes through a combination of theoretical models, laboratory experiments, and observational studies. The Kuiper Belt's composition and the types of objects found there are crucial in understanding its potential effects on Earth's atmosphere and climate. The belt is primarily composed of small, icy bodies, including dwarf planets, comets, and asteroids. These objects are remnants from the formation of our solar system and provide valuable insights into its early history. The interaction of these objects with the solar system, particularly their potential effects on Earth's atmosphere and climate, is a key area of research. For instance, the icy bodies in the Kuiper Belt can release gases as they approach the Sun, contributing to the solar system's overall gas content and potentially influencing Earth's atmospheric chemistry. The objects in the Kuiper Belt interact with the solar system in complex ways, with their orbits being influenced by the gravitational pull of the major planets, particularly Neptune. This gravitational influence can cause the orbits of Kuiper Belt objects to become unstable, leading to their ejection into the inner solar system, where they can interact with Earth's atmosphere. The study of these interactions is essential for understanding the potential climate impacts of Kuiper Belt activity. Furthermore, the composition of the objects in the Kuiper Belt, including their ice content and rocky components, plays a crucial role in determining their potential effects on Earth's climate. For example, icy bodies can release volatiles, such as water vapor and methane, as they approach the Sun, which can then interact with Earth's atmosphere. The types of objects found in the Kuiper Belt also vary significantly, ranging from small, icy bodies to larger, more rocky objects. Each of these object types has the potential to influence Earth's climate in different ways. For instance, smaller, icy bodies can release large amounts of dust and gas as they approach the Sun, potentially cooling Earth's climate. On the other hand, larger, rocky objects can have significant effects on Earth's orbit and the distribution of solar energy the planet receives. Understanding the diversity of objects in the Kuiper Belt and their potential climate impacts is an active area of research, with scientists using a combination of observational and theoretical approaches to study these objects and their effects on our planet. A key moment in understanding the connection between Kuiper Belt activity and climate change came with the discovery of the dwarf planet, Eris. Eris, located in the outer reaches of the Kuiper Belt, is slightly larger than Pluto and has a highly eccentric orbit, which takes it from the outer edge of the Kuiper Belt to distances beyond Neptune's orbit. The discovery of Eris and other similar objects has shed light on the complexity and diversity of the Kuiper Belt, highlighting the potential for these objects to influence Earth's climate. The study of Eris and other Kuiper Belt objects has also led to a greater understanding of the early history of our solar system and the processes that shape the formation of our planets. The discovery of Eris and the subsequent study of its orbit and composition have significant implications for our understanding of the Kuiper Belt's potential climate impacts. For example, the highly eccentric orbit of Eris suggests that it could have a substantial influence on the distribution of solar energy Earth receives, potentially affecting our planet's climate. Furthermore, the composition of Eris, which is believed to be primarily icy, indicates that it could release large amounts of volatiles as it approaches the Sun, potentially interacting with Earth's atmosphere. The study of Eris and other Kuiper Belt objects like it continues to be an active area of research, with scientists using advanced telescopes and computational models to better understand their orbits, compositions, and potential climate effects. Recent research findings have also highlighted the importance of the Kuiper Belt in understanding Earth's climate. For example, studies have shown that the Kuiper Belt has been a significant source of comets that have impacted Earth's climate in the past. These comets, which originate from the Kuiper Belt, can release large amounts of dust and gas as they approach the Sun, potentially cooling Earth's climate. The study of these comets and their effects on our planet is essential for understanding the complex interactions between the Kuiper Belt and Earth's climate. Furthermore, the discovery of new Kuiper Belt objects and the study of their orbits and compositions continue to shed light on the potential climate impacts of these objects. The connection between Kuiper Belt activity and climate change is also being studied through the use of advanced computer models and observational data. These models and data are helping scientists to better understand the complex interactions between the Kuiper Belt and Earth's climate, including the effects of comet activity, asteroid collisions, and the release of volatiles from icy bodies. The study of these interactions is crucial for understanding the potential climate impacts of the Kuiper Belt and for predicting how these impacts may change in the future. By examining the historical record of Kuiper Belt activity and its effects on Earth's climate, scientists can gain insights into the potential future impacts of this activity and how it may influence our planet's climate. In summary, the Kuiper Belt plays a significant role in shaping Earth's climate, through phenomena such as comet activity, asteroid collisions, and the release of volatiles from icy bodies. The study of these phenomena and their potential climate impacts is essential for understanding the complex interactions between the Kuiper Belt and our planet. By examining the composition and diversity of objects in the Kuiper Belt, as well as their interactions with the solar system, scientists can gain valuable insights into the potential climate effects of this region. The importance of studying the Kuiper Belt for understanding Earth's climate and predicting its future cannot be overstated, as it holds the key to unlocking the secrets of our planet's climate history and its potential future evolution. The potential for the Kuiper Belt to influence Earth's climate is vast and complex, and continued research into this area is essential for advancing our understanding of the interactions between our planet and the outer reaches of the solar system. I'd love to hear your thoughts on the Kuiper Belt's influence on Earth. Do you think it plays a significant role in shaping our climate, or are there other factors at play? Let me know in the comments below, and don't forget to check out my other video on the potential impacts of space weather on Earth's climate, where we explore another fascinating aspect of the complex relationships between our planet and the